After every banana harvest, what remains in the fields is often not abundance, but a massive biological battlefield. Banana stalks hacked down and thrown aside. Water-heavy trunks lying everywhere on the ground, slowly discoloring, slowly rotting, slowly becoming what most people reduce to one simple word: waste. But hidden inside that wet, rough, mud-covered mass is an extraordinary natural fiber structure. Soft, tough, porous, highly absorbent. And if processed the right way, it can cross an almost unthinkable boundary, not into wrapping paper, not into rope, not into decorative material, but into a product that demands extreme standards of hygiene, consistency, and trust: an eco-friendly sanitary pad. This is not just a manufacturing story. This is the story of how modern technology forces something once buried in mud to cross one of the strictest thresholds of all and become a product tied directly to safety, dignity, and intimate human care. And that journey begins with a pile of agricultural waste the industry once left behind without a second thought. Across large-scale banana-growing regions, the fruit is the part the market wants. But the stalk, once it has finished supporting the bunch, is almost immediately removed from the value chain. Too bulky to keep, too water-heavy to transport cheaply, too quick to decay to store for long. So ton after ton, then tens of tons of banana stalks are piled in the fields, left under the sun, soaked by the rain, and left to rot as if they never had any value at all. But this production line sees them differently. Here, banana stalk is not waste. It is biological raw material. Heavy trucks roll one after another into the intake zone. In their beds lie chopped banana stalk sections still coated with mud, roots, plant slime, and the damp breath of the field. Every load crashing into the receiving hopper feels both chaotic and monumental, as if the entire plantation is being swallowed into the stomach of a steel machine. But this is only the beginning. The first problem with this material is not its shape, not its size, but its level of contamination. Mud is embedded deep between the layers. Microorganisms cover the surface. Organic and inorganic impurities are trapped inside the soft plant structure. If the material is not cleaned properly, everything that follows will fail from the very first minute. So the banana stalk surges upward onto the preliminary washing conveyor. High-pressure spray nozzles sweep down like a controlled industrial rainstorm. Water slams into the rough surface, blasting away thick layers of mud and dragging with it sand, leaf fragments, and sticky residue from the field. Immediately after that comes the rotating brush system, powerful brush shafts scraping, sweeping, and scrubbing each stalk continuously, turning a filthy agricultural mass into a material clean enough to move into extraction. This is the first emotional turning point for the viewer, from disorder, dirt, and waste to surprise. If the first section was a cleansing of the surface, this is where the line goes deeper into the true substance of the banana stalk. Because the factory does not want the whole stalk. What it is really hunting for is fiber. Inside the banana stalk is an enormous amount of water. Left intact, the material is heavy, mushy, unstable, and completely unsuitable for a product that must be light, dry, consistent, and absorbent. So the next stage is to break down the raw structure and release the most valuable component. The clean banana stalks are fed into a system of metal compression rollers. Massive rollers spin with steady force, squeezing each piece under intense pressure. Dark, Dirty liquid is driven out in streams, carrying plant sap, organic residue, and the moisture that once made the stalk so heavy. The sound here is not gentle. It is crushing, straining, grinding, tearing. This is the moment the material is forced to surrender its original form. But the most remarkable part is this: the line does not destroy blindly. It separates with intent. Once compressed, the banana stalk is peeled into thinner strips. What was once a bulky plant mass becomes layers of controllable material. And at this stage, the viewer begins to see something unexpected. What looked like wet waste is starting to reveal long, soft fiber bundles with visible order. But it still is not enough. The color is still too dark. The surface is still too coarse. Microscopic contaminants still cling to the fibers. So the membrane strips continue into combing and refining systems. Rows of mechanical combs, fine-toothed rollers, and high-intensity wash chambers attack the material all at once. They pull, comb, separate, sift, and rinse it repeatedly to remove hard fibers, excess membrane, and unwanted residues. This becomes one of the most visually satisfying parts of the entire process, because the audience witnesses something rare, a natural material not being pulverized into anonymous pulp, but being liberated into its most elegant structure. The fibers become longer and clearer. The color shifts from dark brown toward a brighter tone. The surface becomes softer and cleaner. This is no longer banana bark. This is technical fiber. And then the first real crescendo arrives. Not when the material is under the greatest pressure, but when it changes color. Because in this line, color change is not just visual. It signals that the material is crossing an invisible border from something that belonged to soil, mud, and decay into something entering the world of hygiene, control, and trust. The refined fibers are spread into thin layers and sent into the drying system. Heat is tightly controlled. Hot air passes through the material, removing the remaining moisture without collapsing the natural porous structure of the fibers. This is a critical engineering balance. Dry too hard, and the fibers become brittle, shrunken, and less absorbent. Dry too gently, and moisture remains, reducing stability and making the core unsuitable for the next stage. So the line does not simply dry the fiber. It engineers loft. When the material exits the drying chamber, what remains is a light, bright, airy, soft plant-based cotton-like layer. It no longer resembles banana stalk at all. It looks much closer to an industrial absorbent core than anyone would have imagined possible. This is the moment the audience moves from surprise to satisfaction, because the transformation is no longer a promise. It is visible, but everything so far is only half the journey, because clean, soft, highly absorbent fiber is still not a sanitary pad. Between those two things lies a very large gap. The gap of shaping, of leak control, of moisture barriers, of structural stability during use, and above all, of trust. This is the point where the line stops merely processing material. It starts manufacturing a product. The fluffy fiber layer moves into a precision flattening and metering system. Rollers compress it lightly but accurately, turning the airy plant mat into a more stable surface that cutting and stamping equipment can handle with minimal deviation. From there, the continuous sheet is cut into absorbent cores of standardized dimensions. Each press stroke is a moment where chaos is forced into form. Each core cutout is a declaration that this natural fiber has matured enough to become a real product. But shape alone is not enough. A good sanitary pad must not only absorb. It must hold liquid in the right place, reduce overflow, maintain structure during motion, and create a sense of reliability in use. That is why embossing appears as one of the final smart engineering layers. Metal rollers engraved with patterns move across the surface, pressing in channels that guide fluid flow. This is a small detail most users never think about, but inside the factory it functions as microarchitecture. Where liquid will move, how it will spread, where it will be held. All of that begins with these seemingly simple embossed grooves. Immediately after that, the waterproof backsheet is laminated onto the underside. A protective release paper for the adhesive strip is precisely attached to the back. Different materials, from plant fiber to technical films, are no longer separate elements now. They are being locked together into one unified structure. And then the line reaches the most tense moment in the entire process: sterilization. This is the point where every wow moment, every beautiful image, and every green promise becomes meaningless if it fails, because the audience still remembers exactly where this material began. In a banana stalk lying in the field, covered in dirt, wet residue, and biological decay. Once the product passes sterilization, it is functionally complete. But to truly enter the market, it must move into another world: the world of packaging, uniformity, and logistics. Each sanitary pad is folded neatly by mechanical guiding arms and precision alignment systems. Thin packaging film is drawn down around the product and sealed shut with heat in a rhythm that is fast, clean, and mercilessly consistent. In just seconds, a material that once grew in muddy fields becomes a hygienic, discreet consumer unit ready for the modern retail shelf. If the first half of the factory looked like a machine stripping away the roughness of nature, this section looks like a machine manufacturing absolute order. No piece sits out of line, no fold is wasted, no bead is missed. Each individually wrapped product continues toward pack assembly. Their multi-axis robotic arms begin the most visually elegant part of modern packaging. Vacuum heads drop, lift, rotate, place, adjust, and stack. Their motion is fast, but never rushed. Precise, but never clumsy. It feels as if the entire room is controlled by an invisible rhythm where every product already knows exactly where it belongs. Small paper cartons are formed, opened, filled, and closed. Their edges are sealed. Batch codes are printed. Rows of finished retail packs race onward, ready to be loaded into larger shipping cartons. And once again, the robots take over. They do not tire. They do not drift. They do not miss. Shipping cartons full of product are folded, taped, weight-checked, and pushed toward the palletizing zone. There, the cartons are stacked into clean, stable blocks. Stretch film wraps around the entire load, cinching it tight like a final protective shell before dispatch. Forklifts move in, lift the pallet, turn, and carry it toward the warehouse doors. By this point, what the viewer feels is no longer just technology. It is scale, because a green idea only matters when it does not remain a beautiful handcrafted concept for photographs. It has to scale into mass production, into logistics, into the market, into thousands, then millions of units capable of replacing part of an existing system. This is where early excitement turns into respect. But if the story ended here, it would still be only a very good factory. Impressive, clean, modern, but still just manufacturing. The real twist comes at the end, because in a normal factory, everything that falls away from the fiber extraction process would be called waste. Broken peel, banana pulp, roots, rejected fibers, organic debris, all of it would simply become material to dispose of. Here, The system sees those leftovers as part of an unfinished cycle. All organic byproducts from the early stages are collected on separate conveyors, not thrown together, not buried immediately, not left to rot at random. They are redirected to another production stream, where value does not end, it simply changes form. Grinding machines come alive. Wet masses of pulp are chopped, shredded, and reduced to uniform size. Then mixing systems transfer them into conditioning chambers, where microbial solutions are sprayed in to begin controlled fermentation. This is no longer part of the hygiene line. This is the part that belongs to the soil. Quietly, almost elegantly, the same material that came from banana fields is preparing to return to agriculture. After fermentation, the organic mixture moves into drying and stabilization. Excess moisture is removed. Heavy fermentation odors are reduced. The structure becomes lighter and more consistent. Then screening systems remove any material outside target size before it enters granulation equipment. Here, the final byproduct is compacted into small, uniform organic fertilizer granules that are easy to store, transport, and distribute. This is the deepest payoff of the entire film, because the audience realizes something important. This factory is not just taking the best part of the banana stalk and discarding the rest more politely. It is trying to close the fate of the entire material. The finest fiber becomes the sanitary pad core. The remaining organic mass becomes fertilizer, which means what was thrown away at the beginning of the story returns to nourish the very fields of the future. That is what zero waste really means. Not a slogan, not a green color printed on packaging, but an industrial logic that stretches value to the final possible fragment. The fertilizer granules are automatically packed into eco-friendly bags, sealed, stacked, and shipped out. One stream enters consumer care. Another returns to agriculture. Two product lines leave the factory from the same original source. And the banana stalk, once dismissed as post-harvest waste, no longer ends in meaningless decay. It is reborn twice, once as a product for human care, and once as nourishment returned to the soil. This is the unique beauty of modern industry when aimed at the right problem. It does not just produce faster, not just cleaner, not just better looking. It re-examines what society has ignored and builds a system intelligent enough to rewrite its value from the ground up. From banana stalks discarded in the field, through washing, pressing, refining, drying, core formation, embossing, lamination, sterilization, and packaging, until they emerge as finished bio-based sanitary pads. And then, from the remaining pulp, through grinding, fermentation, drying, screening, and granulation, until it becomes organic fertilizer returned to agriculture. One material, two new lives, almost nothing wasted. What makes this process truly remarkable is not just the robots, the conveyors, or the UV chamber. It is the philosophy behind them all. In the right era, waste does not have to be the end of a story. It can simply be raw material waiting for a technology capable of understanding it. And perhaps that is the most memorable image of all. Not a banana field littered with cut-down stalks after harvest, but the moment those stalks pass through steel, water, heat, light, and machine precision and become something cleaner, more useful, more civilized for human life. And then the rest goes back to feed the soil. A closed loop, a double rebirth, and a powerful reminder that the future of manufacturing does not belong to making more at any cost, but to learning how not to waste what the world has already given us in the first place.